As communications service providers focus on securing network energy performance and achieving sustainability goals, the best network no longer means just fast and reliable. It's time to redefine the best network as high-performing, energy-efficient, and sustainable. Welcome back to another exciting episode of the Imagine Studio Unboxed. I'm Bhushan Joshi, Head of Sustainability for Ericsson in North America. Today, I'll be your host as we explore how the Ericsson portfolio, especially the hardware aspects of the Ericsson Radio System, can help CSPs or cellular service providers achieve their NetZero targets. So let's talk with Shashika Senavaratne, Director of Network Sustainability, and learn more. Hey, Shashika.
Hey, Bhushan.
Great to see you, and thank you so much for joining us.
My pleasure.
Wonderful. Let's get right into it. So the telecom sector has agreed on a science-based pathway to reach net zero emissions by 2050 or sooner. And we know that RAN accounts for 80% of the energy consumption in mobile networks. And it's also a major source of carbon emissions for CSPs. So how is Ericsson helping cellular service providers address this key challenge?
Yeah, and you mentioned a very good point. So prioritizing RAN places a key role in reducing the energy consumption, reaching the sustainability goals, and helping operators reduce their OpEx as well. Now, we have a few levers in the RAN domain that we can use. We can use hardware, software, AI, ML, all working holistically to reduce the consumption and increasing the capacity of the network. Right? So today's episode, because we are focusing on hardware, let's dive into some key technology enablers in hardware. So out of that 80% that you mentioned, majority of it is consumed by the radio. So let's start with the radio. Now, one key aspect to look at is consolidation of different capabilities and functionalities into a single radio as much as possible. So we can look at multiple frequency bands that can be consolidated into a single radio. So increase of capacity comes with adding new frequency bands. So how do we consolidate as many of those bands into one radio? So 4 frequency bands consolidated into one radio as a quad band radio compared to having 4 single band radios. And then also consolidating of different technologies, having 4G and 5G consolidated, supported by a single radio. So that's a great case for network modernization. Operators can start with their 4G and use the same hardware to modernize to 5G. And then consolidation of spectrum usage technologies like TDD and FDD supported in a single radio. And the other part of that is using the most energy efficient components within the radio. So as an example, using highly efficient power amplifier technology, which is the most energy consuming block in the radio with gallium nitride, or low insertion loss filters that impacts the consumption of the power amplifier as well. All this leads to reduced energy consumption of the radio. And the next part of it is once you have the least energy consuming blocks, how do we turn them off as much as possible for the longest period of time without impacting the user experience with dynamic traffic? And that's where the software and the AI ML component comes into play, which we'll be covering on a different episode, I believe, right?
Right.
And then, of course, the last part of is the size and the weight of the radios that can be improved by using advanced heat sinking technologies like thermosiphon and vapor chambers. Again, the smaller the size, the less carbon footprint you'll use for transportation, less space you'll use on the tower, and then one-person installation that's impacting less cost, so overall reduction in TCO as well.
Great.
Now, on the baseband side, our newest basebands, they support 4 times more spectrum capacity while keeping the same energy consumption. So doing more with less, right? And all this requires high amount of processing power. And that's where Ericsson Silicon comes into supporting highest level of processing, then high capacity, supporting wide bandwidth, all supported and by Ericsson Silicon as a key building block in a hardware designs.
So I mean, and that's great, right? So to me, what it sounds like is that modernization is key to scaling 5G sustainably. And when you modernize, you are able to consolidate and reduce the physical footprint. That drives a bunch of benefits, reduced energy consumption, increased capacity, and then lower embodied carbon footprints that come with the product manufacturing and also transportation. So I think that's a really key thing to point out. Let's go to the next question now. So with all of that, we still know that the global mobile data traffic is going to grow more than 3 times over just the next 5 years. And that poses a challenge. So how can CSPs more effectively prioritize some of these strategies that you talked about and deploy them to achieve their business and sustainability objectives?
Yeah. Planning, operating, and deploying the network with sustainability in mind is key.
Great.
Right? Now, as long as there is the handset penetration for 5G, taking advantage of 5G becomes a key because 5G is the most energy-aware technology we have today. So with NR, which is the technology for 5G, CSPs can transmit data much faster and return to idle mode much faster. And NR also uses less control signaling. So they can take advantage of these sleep modes for longer period of time more frequently. And then for high capacity sites, taking advantage of NR-TDD massive MIMO radios. And we've seen field trial data where 13 times more data volume is transmitted with the same amount of energy, meaning that for 1 gigabyte of data, it's 13 times more energy efficient, right? And then still for lower capacity site and existing radios, operators can still use software to turn them off as frequently as possible with dynamic traffic patterns. So taking advantage of existing hardware and focusing on modernization as soon as possible is a key.
Great. So that kind of really provides almost a roadmap of how CSP should go about doing this. Let's jump to the final question. So the final question, we expect that future mobile networks will include Open RAN architectures. What is Ericsson doing to take some of the insights that we have from providing energy efficiency in purpose-built RAN over to the Open RAN architecture?
Yeah. So when we talk about Open RAN, there's 3 key pillars. The cloudification, open front haul, essentially that's the interface between the radio and the baseband, and then open platform and automation. Now, all these enables energy efficiency to be transferred into the Open RAN space as well. Now, if we talk about open front haul, what that enables is the current radio technology advancements in energy efficiency and sustainability to be used in Open RAN as well. Now, in the cloudification space, that's really creating an ecosystem of partners to work on these energy efficiency aspects. Now, there is a proverb that says it takes a village to raise a child. So it takes a village to create an Open RAN ecosystem. So we work with partners like Intel and AMD for our CPUs and for servers, partners like Dell and HPE, where we are working on the hardware and the software aspects of reduction of consumption in the Open RAN space. Now, as an example, we can take advantage of C states, essentially on the CPUs, that's shutting down CPU cores based on utilization. So those kind of technology advancements are being worked with our partners. And then the final part of it is automation and open platform. So we have our apps that we've developed that is essentially the apps that can run on the management orchestration platform in the RAN architecture, which is called SMO, which supports energy efficiency. So RAN Energy Cockpit and RAN Energy Control, those are the 2 our apps that we have released. So the learnings that we have from purpose build is transferred to the Open RAN space through these R apps.
So it's clear to me that cooperation and collaboration throughout this ecosystem is really what's going to allow us to bring the same benefits from energy efficiency that we had with purpose build into the Open RAN architecture. And it's really good to see Ericsson's leadership in here as well. Perfect. So that's all the time that we have today. But thank you again for your time, Shashika. And now we're going to head over to the Ericsson studio and take a more deeper look at the Ericsson RAN portfolio, a hardware portfolio, and talk a little bit more about the sustainability benefits. Thank you so much. Welcome back to the Imagine Studio. And today we have Declan Quinn, Director of 5G Networks, with us. Hey, Declan, thanks for joining us.
Thanks for having me, Bhushan.
Awesome. So in the context of energy efficiency in 5G RAN, hardware plays a crucial role in making 5G networks more energy efficient and delivering the best end user experience. So let's take a deep dive with Declan and learn more about Ericsson's RAN hardware portfolio. Hey Declan, can you provide us an overview of the key energy efficiency features of the RAN portfolio?
Yes, Bhushan, for sure. So we have a number of elements in our hardware portfolio ranging from passive antennas all the way to micro radios and dot radios, which are used for indoors.
Okay.
So we have some of the most energy efficient products in the marketplace today. We can start with our passive antennas. We can move to our interleaved antenna here. This allows us to have a single antenna position with a highly efficient antenna, up to 85% efficiency now of translating from your RF output power to the actual emitted output power from the antenna.
Okay.
It also allows us to have multiple bands from low band to mid band, FDD bands, and then also our 3.5 gigahertz TDD radio, which actually sits behind the antenna.
Okay.
This allows us to have a single antenna position, which reduces the weight and wind load on a site.
So this is truly doing more with less in some way.
It certainly is. A single antenna position can have 5 bands of radio frequency on a single position.
That's great. That's great.
And then we can move to our active antenna systems, our AIR products, or antenna integrated radio.
Okay.
These, along with all of our active products, are built in our Ericsson silicon, which enables us to have many energy-saving features, including things like deep sleep for our radios, to reduce the power consumption by up to 93% when the radio is not being used.
Wow.
So there's an enormous reduction in the energy consumption of the radio as a whole. So this is a massive improvement. These run from 16T, so 16 transmit and receive branches, all the way up to 64T, so 64 transmit and receive branches in a single antenna unit. The efficiency is there as well because we actually remove some of the loss-making components like jumpers, which would be just pure loss. We now actually put the radio directly connected to the antenna element, which again improves the energy efficiency of the radio.
So really designing for energy efficiency and then also making sure that the network is on when you need it, but not always on.
Exactly. And so we bring other elements and other software features, which are again enabled by our silicon, by Microsleep TX. And then in the future, we'll have things like booster carrier sleep, which just enable the bands when you need them. So again, reducing the energy consumption on site, helping our environment.
Great. And with OpEx being such a huge, network energy OpEx being a big expense category for CSPs out there, solutions like these are increasingly even more important.
It is, because the radios themselves consume a lot of energy as part of the overall energy bill of our tier 1 customers, our customers.
Right.
So we need to be able to reduce that as much as possible, and using these intelligent features enables that.
Perfect. All right. I know you wanted to walk us through some other products here.
Yeah, so we have some other additional products that we have in the the remote radios portfolio.
Okay.
So we have some of our newest radios, which have an improved energy efficiency now compared to their predecessors of up to over 20% efficiency by comparison to its predecessor. But it also allows us to have higher output power as well. So this enables a larger reach, which potentially enables less sites in the network. Again, having higher energy efficiency and less number of sites.
Fewer sites.
Yes.
Less energy usage.
Exactly, overall. So that's one of the keys that we're going to be able to put in the network. Great. These are also smaller and lighter, which again enables the reduction of the amount of steel that would be required on site.
Right.
We understand that steel obviously has a major impact on sustainability. So using less steel and reusing a lot of elements means that we don't have to reproduce them again, which again improves the overall sustainability of our network.
Yeah, totally. Our customers are setting NetZero targets that extend into the value chain. So these products have a lower embodied carbon footprint now because they're made from fewer materials, and they provide more with less.
Exactly, and that's definitely one of the goals of us at Ericsson, is to reduce that embodied carbon footprint of all of our products when it comes to packaging, transport, manufacturing locally, like we are here in the US, so we don't have to transit products from around the world to the US. We can build them here and then deploy them here in the United States.
Great, wonderful. So I think, so thank you, Declan, so much for providing us a really excellent overview of the RAN portfolio, hardware solutions, specifically in the context of energy efficiency. We thank you all so much for joining us today for this exciting episode of the Imagine Studio Unboxed. We look forward to seeing you soon in the next episode as we continue to redefine the best network to be energy efficient, sustainable, and high performing. Thank you.